Hi, everybody. So today we are going to be moving on and learning more about volume. We are on lesson 1.7. I think I probably should have shown that to you first. We're going to be measuring volume today by counting cubes. So we've already learned that volume is defined by an object that takes up space, and it is a three-dimensional object. And it is an object that has thickness. So again, when we talk about the differences between volume and area, area is two-dimensional, volume is three-dimensional. Area is measured in square units for two, and volume is measured in units. We'll find out today. Perhaps you have a prediction on what unit volume is measured in. So make sure you have your dry erase board out. Make sure you have your marker, your eraser, your math journal, and you're ready to start with your warm-up. But before we go into our warm-up, as a reminder, today for our objective, we will be discussing the benefits of using unit cubes to measure volume. And we will measure volume by counting the number of cubes it takes to fill a rectangular prism. So as I had mentioned, there are going to be a couple of different ways that you can find the volume of a prism. And today is going to be the first method, which is counting cubes. So let's get started with our warm-up. So here is our mental math and fluency. As I have mentioned before, this is a power standard in 5th grade. So you should be able to do these accurately by the end of the year, which is solving these expressions using your order of operations. So remember PEMDAS, PEMDAS, parentheses comes first, exponents, then multiply, divide, then add and subtract. So go ahead and pause this video and take a moment to solve these problems. Okay, so let's take a look and go through the answers. And just a reminder, 5th grade, these reflexes are for your benefit. So hopefully you take your time on them and you try your best so that you're practicing and getting better at math. So again, we start with 2 plus 3 first, which is 5, and then I multiply it by 2, which gives me 10. 2 times 2 first, which is 4, plus 3 gives me 7. Again, in the 2-star problems, I'm going to do my parentheses first. 24 divided by 4 is 6, plus 8 is 14. 18 divided by 3 I do first, which is 6, plus 5 is 11. And then 56 divided by 8 is 7. 7 times 10 is 70. So if you've gotten them all correct so far, way to go. For this one, I can do them either way because they're both in parentheses. So 3 times 2 is 6, plus 4 times 3 is 12. Together they make 18. 42 divided by 6, I can do that first, which is 7, times 27 divided by 3, which is 3. 7 times 3 is 21. And then the last one, I would do 48 divided by 8 first, which is 6. Then I have to do 12 plus 6 first because the order of operations says once I get to adding and subtracting, I have to go from left to right if I have both of them left. And because I have adding and subtracting left, I have to move from left to right. So 48 divided by 8 is 6. And I go to 12. 12 plus 6 is 18. Minus 7 is 11. If you got the last one correct, that's really, really great because that one's kind of tricky because you have to know the order of operations really well. So let's move on from our warm-up and we're going to go into our math journal. So you should be open to page 18 in your math journal. And I'm also referencing a sheet that you're going to find in the back of your math journal. So here I am on page 18, and there's little activity sheets at the back of your math journal. And this one is activity sheet 1. And you don't necessarily have to rip it out for this activity because I'm going to show you what I'd want you to do if you were in class. But you could build these later, because I will tell you that fifth graders love building these prisms. You get to make little fun shapes to determine their volume. And if you don't have the cubes at home to measure, it's going to be hard to do this, but you can still build them later after the lesson. So I wouldn't build them now, but if you want, you can build them later. And it's using the activity sheet 1 in the back of your math journal. So I have already done this for you basically, and I've built 3 prisms, okay? And I'm going to show you these prisms on my camera here, and I'm going to have you estimate how many cubes fit into the prism, okay? So I have 3 cubes, and you'll see, well, they're actually called prisms, my apologies. I have 3 prisms, A, B, and C. And you will see on your math journal that it says, record your estimates from the math message in the second column on the table. Record the actual number of cubes you used to fill the prism in the third column of the table. So what you're supposed to do is you're supposed to estimate how many cubes will fit into each of these prisms. Now, my question to you that I want you to think about is, why wouldn't I measure it with a square pattern block? Why wouldn't I measure these with a hexagon pattern block? Why wouldn't I measure them with triangle pattern blocks? Better yet, why wouldn't I fill these up with diamond pattern blocks? And so I want you to be thinking about that too as I go through this lesson. Why would I not want to measure volume with these shapes? Why would I want to measure volume with a cube like this? Why would this be better? So take a moment to think about how many of these cubes will fit into prism A, prism B, and prism C. So I will show you each of these. You can also look at your activity sheet 1 or at this Google slide because it might come in handy. So here is prism A. And you can pause the video at any time to help you figure out. So there's the side of prism A. There's the bottom of prism A. And there's the width of prism A. Okay, so how many cubes do you think will fill prism A? Okay. Here's prism B. How many cubes do you think will fill prism B? Here's the bottom. Okay, and I know it's hard because you're not here in person with me to see this, but there are ways that you could tell how many cubes fit in this prism. That's B. And then here's prism C. Here's the bottom of prism C. So go ahead and fill out column 2, make an estimate for how many cubes you think will fill each of these prisms. Okay, so you should have had a moment to estimate how many cubes will fit into each prism. So let's take a look at prism A. I have filled prism A with 1 layer so far. So what that means is that there's 1 layer of cubes in here. And when you look at the cube here, or the prism, I'm sorry, you actually have 3 layers. 1 layer at the bottom, 2, 3. And that's kind of like what I would call the height of my prism. So I've got 1 layer. So how many cubes make up 1 layer? And I know the white ones are hard to see. Right, there are 8 cubes that make up 1 layer. So rather than filling the whole entire thing, I could do 8 times 3 because there are 3 layers in this prism. So if I filled this up with 2 more layers, I would be able to tell that 24 cubes fit into this prism because 8 times 3 is 24. Okay, so for prism A, you should have gotten 24 cubes. Okay, so again, today is all about counting cubes. My second prism is prism B. And again, I've only filled one layer of prism B, so you can see that there's still one more layer to go because again, when I look on the side of my prism, I can see that there are actually 2 layers to this prism. So layer 1 is what I've just done. Layer 2 is right here. So I have layer 1, and in one layer I can fit 1, 2, 3, 4, 5 times 2 is 10. So I can fit 10 cubes in one layer. If there are 2 layers, how many cubes fit this whole entire prism? 20. So the actual number of cubes to fill the prism is 20. So you should fill that out on your third column under prism B, because that is the actual. Maybe you guessed it correct, maybe you didn't guess it correct, but either way, please put down the correct number of cubes to fill this prism, which is 20. Okay, and then the last prism is prism C. Again, I have filled it with one layer, and in one layer, how many cubes can I fit? I can fit 9 cubes. And how many layers are there? There are 2 layers to this prism. 1, 2. Again, when I think of layer, I think of height. What is the height of this? So if 9 fit one layer and I have 2 layers, how many cubes fill the whole prism? You should have said 18. So the actual number of cubes to fill prism C would be 18. Now, I want you to notice one thing. I want you to notice how nicely packed these cubes are in my prism. Notice how there are no gaps in there and there are no overlaps. They fit nice and tight in that one, and this one, and in this one. And if I were to fill a prism with what I had showed you earlier, if I were to take this prism, which is a little toothpick box, and I were to fill it with hexagon pieces, wouldn't I have gaps and overlaps? They don't fit all nice and tight like they do in here. So I also know that triangles wouldn't fit nice and tight in here. There would be gaps in here because they wouldn't fit all around perfectly even. And I know the same thing for diamonds, okay? So one of the things that you have to understand about cubes, see, so there's gaps. One of the things that you need to understand about these cubes is that they fit and nice and tight without any gaps or overlaps. You're going to want to always remember that. Cubes are the best unit to measure volume with because unlike these shapes, there are no gaps or overlaps in my prism. Okay? So as I was mentioning, let's compare a square pattern block to a centimeter cube. So on the right, this is what we use to measure our prisms just now. On the left is a square pattern block. And we're going to discuss why we wouldn't want to use a square pattern block to measure volume and why the cube is better. So could both shapes be used to pack a prism without gaps or overlaps? Yeah, because they're both squares essentially. Could both shapes fit in the corners of a prism? Yeah, because remember, a prism, in this case, we have is a square. Do you think a cube or a square pattern block is better for measuring volume? Why? Well, I've kind of already given you the answer, so you should say a cube. But why would a cube be a better unit to measure volume with? Think about the size of a cube versus the size of a square pattern block. What do you notice about the sides of the cube versus the sides of the pattern block? Ask yourself, are they the same all around? Could that make it hard to have gaps or overlaps if they're not the same all around? A cube is better. Since each edge length is exactly the same number of cubes will fit in a row in the prism no matter which way you turn it. The edges on a square pattern block are not all the same length. Because the height is smaller than the length and the width, it fits differently if it's on its side rather than if it has the square part on the bottom. So depending on the way that you lay this can determine how many you can fit or if you'll have gaps or overlaps because the sides are not all the same. So hopefully that makes more sense as to why we use a unit cube to measure volume and why we don't use a pattern block that's a square. Today we will use cubes to measure the volume of rectangular prisms. When you pack the prism with pattern blocks, when you pack the prisms with pattern blocks, you will report your results as a number of pattern block units. When cubes are used to measure, each cube has a side length of 1 unit and is called a unit cube. Its volume is 1 cubic unit. Cubic units can also be written as units cubed. So if you look here, 5th grade, it's important that you see how to write this. Units with a little 3. Why? Because this is cubic, and cubic means 3, right? There are 3 dimensions to something that is a cube: length, width, and height, okay? So that's why we measure volume with cubic units, and because this is 1 unit cube, and this is what we used to pack our prisms. So remember to pack without gaps or overlaps, and that is common throughout all of volume. We do not want to have gaps or overlaps when we're measuring volume, and that is why we use a unit cube to measure volume. Not rice kernels, not popcorn, not hexagons, not diamonds. We use the unit cube to measure volume. So as a little review here, we figured out that 24 cubes fit into prism A. The question then becomes, what is the volume of prism A? It is not a trick question. All you need is a unit. The volume is 24 cubic units. Why is the number of cubes you use to fill the prism the same as the volume of the prism? Because 1 cube has a volume of 1 cubic unit. If I count the total number of cubes, it gives the number of cubic units that fill the prism. That's the volume, so it's the same. However many of these is however many cubic units the prism holds, which is its volume. Okay, so the same thing goes for B and C, which we've already done, but to go over, prism B we know had 20 cubes that filled the prism, so 20 cubic units would be its volume. Prism C, how would you write that as volume? So we know that 18 cubes fit into prism C. What would be the answer to what is its volume? 18 cubic units. So let's see if you were paying attention here. Of the different materials that we have used to measure volume, whether it be packing material, pattern blocks, popcorn kernels, or cubes, which unit do you think results in the most accurate measurement? Why? So pause the video here and think for a moment, which of those would be the best unit to measure and why? Cubes provide the most accurate measurement because they can be packed tightly without gaps or overlaps. They're small, so it's easy to fill the container almost exactly. I will ask you all year about this question, so remember, ingrain it in your head. Why are cubes better to measure for volume? Because there are no gaps or overlaps and they fit into the corners nicely. Just drill that into your head, okay, fifth grade? Okay, so we're still on page 18. We're going to do 2 practice problems together before we come back as a whole class. So it says the cubes in each rectangular prism below are the same size. So they're all this big. Each prism has at least one stack of cubes that goes up to the top. Find the total number of cubes needed to completely fill each prism. So you might be saying, well, Miss Williams, I thought today we were counting cubes and to figure out our volume, and I know that not all the cubes are in these prisms, so how am I supposed to count all these if there are some missing? So what could we do to help us figure out the volume of each of these prisms? Is there something that I can use to help me figure it out? Maybe, I think you said, Mrs. Williams, there's length, there's width, and there's height, so why don't I just count the cubes and figure out the length, count them, figure out the height, count them, and figure out the width? Gee, if you said that, that's a novel idea. That's exactly what I'm going to do. So I'm going to take a look at prism 1. And it doesn't really matter which dimension you start with, but I'm going to start with the dimension that goes from left to right, so we'll call that our width. So there's 1 cube, 2 cube, 3 cube, and there's actually one hiding underneath, and this is where 5th graders get confused because they don't see it, but there's actually one there. So we're going to put a little dot there, 4, 5, 6. So the width I'm going to say is 6, and you can write this on your paper. Then I would want to find, probably I'll find my length next, so going from front to back. And it doesn't really matter what order you multiply these in, because according to the associative property in math, no matter which way you multiply, you'll still get the same answer. So it doesn't really matter how you multiply these numbers in the end. So we're going to go from front to back. So let's see. So there's 1, 2, 3, 4, and then again, there's 1 tucked in back. And I just try to visualize, so that would be 5, but I just try to visualize what is there that I can't see. And I know that there's 1 back there. So 1, 2, 3, 4, 5. And then I need to figure out what my height is. So there's 1 here, 2 here, 3 here. I'm sorry, I should make my dots. 2, 3. And again, there's 1 tucked underneath. So there's 1 tucked underneath for all of that. So 4 would be the height. So go ahead and see if you can figure out what is the total volume for that prism. Okay, so you should have had a moment to figure out what the volume is for this guy. And I'm going to do 5 times 4 first, which is 20. And then I'm going to do 20 times 6, which is 120. So I know that 120 cubes will fill this prism. So what is the volume of prism 1? Good. You should have said 120 cubic units. It will be the same because however many cubes fill the prism is however many cubic units it is for its volume. So go ahead and pause the video and see if you can try to do problem 2. Okay, so let's take a look. I'm going to look at my width first. How many cubes go from left to right? 1, 2, 3, 4, 5. And then here's where it kind of gets tricky. There's nothing here, so I like to imagine pushing these cubes to the front. And there's 1 there, so that would be 6. There's 1 there, that would be 7. And then there's 1 there, that would be 8. Again, imagine pushing them to the front. How many more would you have? You should have 8 there. My height, I'm going to use a different color so it's easier to see. My height is Starting from the bottom, 1, 2, 3, 4, 5. And then probably the hardest one here is the width. I'm sorry, the length. We already did the width. This one's tricky because it's really hard to see what's going from front to back. So you have to kind of imagine where all these cubes are lined up. So what I'm going to do is imagine these cubes being pushed all the way to the side. So when I do that, I'm going to push them to the left side because it's easier for me to see that. So if I push them over, I know I have 1 here, 2 here, 3 here, and 4 here. So I know that my length is 4. Okay, so now that I have all of my dimensions figured out, I can just multiply my numbers together because I know that that's the formula for volume. I can just multiply my length, my width, and my height. So 8 times 5 is 40, times 4 is 160, or I could do 4 times 5 first, which is 20. 20 times 8 is 160. And then what would my volume be? You should have said, Miss Williams, it will be the same, 160 cubic units, which is correct. Okay, so I can't tell you enough, fifth grade, how hard these can be, these problems, because you have to really imagine these cubes pushed across the prism to help you figure out your dimensions in order to count your cubes. So I would like for you to take your journal. You're going to come back to our Google Meet where we will go through page 19 either together or independently. So you may now return back to the Google Meet for your next set of directions.